Yeah, g'day and welcome back. This is a Schaublin 125 CNC lathe. It was the cheapest one in Europe. I bought it because I like lathes. We've had quite a few new subscribers lately, so I thought I'd better give a quick summary of what I've done so far. First, got it delivered. It was bought in Switzerland. I did a video on the old controller. Next video I made was sort of testing some of the things, testing the spindle. The next few videos were all just various aspects of stripping things down, cleaning, inspecting, terminating with the spindle, which I pulled in the last video. I appreciate all the good feedback I got from everyone about these bearings. I've decided I'm not going to demount them. I'm going to leave them on the spindle. I'll get a container, soak them initially with diesel. Probably have to soak it, blow them out, soak it, blow them out. Do the final cleaning in mineral spirits. Once again, good blowout. Make sure I get everything nice and clean. And I need to order some Kluber LDS18. I've got Kluber NUB15 because that's used on my Mahu mill, but it's not the right one. The gentleman who signed off this machine at Schaublin back in 1981 contacted me again and sent me the original production card. They started the final acceptance process in November. The customer was the Lathe Control Systems. These are just the internal sign-offs, I guess. Finally went out the door sometime in December 1981 to the customer. Thanks very much, Jean-Claude. That's truly excellent to get this kind of original information for the machine. I needed some sort of a bucket or container. Guess it's plastic surge pipe, so I'll just plug that, fill it with diesel and start it soaking. I will need to cut it down. Just use a bit of wire to make a line. Well, that line didn't work so hot, so I'll try plan B and use a height gauge. Scratch it. First off, I'm just going to soak the whole thing in diesel. I use it mixed with waste vegetable oil in my casting furnace, and therefore it doesn't really matter if I've got some contaminated grease in here, it'll still work. Once I'm down to cleaning with that naphtha or benzene, I won't rotate the bearings. That's a specific warning both in the SKF manual and also in the Schaublin manual. I made a comment about the apprenticeship project, that little vise that I had to make. Well, Nikolai from Nikolai Owns responded with this very cool video showing the amazing things that he built in his apprenticeship. I mean, look at this beautiful bottle jack, huh? How about all of you make a quick video of your apprenticeship projects? I'd love to see them. All right. Oh yes. Look at those. Schaublin B32 collets. Not new. Well, some look new. So that's what I got. All of the whole millimeters from 3 millimeters up to 25, except 16 millimeters missing. And then a few oddballs, 4.5, 8.64, which is really weird. It's not even an imperial size. 9.2, 10.2, and 10.5. Big thanks to Obrad for pointing out this auction. I really appreciate that. And especially big thanks to Alex, who bought the stuff for me down in Serbia and sent it up to me. If anyone happens to have an extra 16 millimeter or has the 0.5 millimeter sizes they'd like to sell to me, please drop me a line. Well, I thought this plate was going to come off quite easily, but I've just realised it's got 2 dowel pins aligning it. So I figured this plate was held with dowel pins, not taper pins, which looks to be correct. What I didn't check was whether I could actually get both of them out. This one was no big deal because its hole was open at the back. I thought the other one was as well. Unfortunately, the top dowel pin is not drilled right through.
Much cleaning later.
Well, that looks a lot better, doesn't it? Is that some sort of clutch mechanism? Some sort of an overload. Oh, that's nice. It pulls off nice and easily. Schaublin's instructions to remove the Z ball screw: put a wooden block across it and then rotate the screw so that it will force the screw out of its bearing. Pretty brutal method, but that's what they recommend. Well, that works nicely. Well, that looks like the reason why the bearings feel all stuck, because it is. That's like hard as chewing gum. And then this one, it's also just a gentle press fit. Also hardened, baked on grease or something down in the bottom. So when I turned it, the spindle, obviously all I did was turn the inner races on their shaft. Anyway, I'll throw those in the ultrasonic cleaner and see what it does to them.
Later.
Okay, so it's still plenty of caked on gunge in there.
Several hours cleaning later.
There was still some sort of asphalt-like gunk on those bearings, so I soaked them overnight in diesel. You can see down here, or maybe you can't see, I don't know. They're marked as being P5 bearings. Must be like one better than P4. So I guess what's that, ABEX 8? My ultrasonic cleaner video generated a fair bit of discussion about whether you should be ultrasonic cleaning bearings or not. Some people say, yeah, of course, that's what everyone does, works fine. Others say, nah, the vibrations make the balls hit the race and causes like micro fretting. I decided to look what the aviation jet engine manufacturers recommend. I think I looked up in General Electric's standard practices, and sure enough, they do allow ultrasonic cleaning. They give a recommendation of a specific frequency. These are higher frequency than recommended. They also recommend a certain amount of power per square inch of base of the tank. Pretty sure this is well under that power level. So this doesn't really meet the standard of the aviation engine manufacturer. At least it's not a completely unknown concept that they tell you not to do at all. Now this first bearing appears to have come out clean. I'll do a final cleaning in white spirits or benzene or whatever you want to call it, wash benzene. This second bearing also seems to have got rid of the worst of the shmoo, all that hardened, caked up, gunged up coolant. Well, maybe there's still a little bit of in there. But I'll leave them soaking in the diesel, it'll keep them protected. Final cleaning before I reinstall them. Well, that can go straight in the ultrasonic. After doing a video on this ultrasonic cleaner, I got a bunch of really good suggestions. One of which was to buzz the thing for 10 minutes to get all the dissolved gases out of the water before using it for cleaning. So I'll do that first. How weird is this? There's like bubbles which are rising to the surface but not making it. They're only coming up to a certain level and then just being stuck. Also a big thank you to one of our viewers, Christoph, who sent me some ultrasonic cleaner fluid and also some citric acid. Cool, I have to try that out.
Much more cleaning later.
Schaublin Z-axis ball screw. This is obviously not some standard part, huh? Looks expensive. Fun fact, most airliners use ball screws. They normally have ball screws to drive out the flaps and also a really big, solid, beefy ball screw to position the stabilizer. It's called the stab trim actuator.
Oh, gross!
It appears that this nut is a press fit into this housing. They don't really need to be separated, I guess. Well, this has now been soaking overnight, so let's just lift it up. And now let's give it a very gentle blow through and see if we can start getting this gunge moving.
much more cleaning later.
Oh good, I got mail. Been waiting for this one. It's what I'm going to use to clean the spindle bearings. I think I've pretty much got everything I need now. Got a lot of really good comments on different sorts of plastic attachments so I wouldn't scratch the bearings, but at the end of the day I couldn't actually get any of them. I just got a normal hypodermic needle, so I'm just going to use the Clarkson with a diamond grinding wheel to make the sharp needle into a blunt needle. And there's the result. Now the reason I pulled this lathe's spindle in the first place was because this encoder belt was dead. And knowing myself as well as I do, as soon as I lubricate the bearings of the headstock, I'm going to want to put that spindle back in. And the chances of me forgetting to put the belt in is real high. I'm going to install two belts, one as a spare. It's the same thing all airliners have with their, like the oleo seals. They always have two in there, one's a spare. If the oleo starts leaking, you don't have to remove the whole landing gear. All you do is drop out the first O-ring, pull the second one down from its storage position, and you can keep going without a gear replacement. Oops, I forgot to turn the mic on there. Sorry about that. Just cleaning out the last of the solvents, blowing it all down. You only fill spindle bearings with about 25% of the available volume. So if you think of a torus the size of the ball diameter minus the volume of the balls, that'll give you the free space in the bearing, and about 25% of that space gets filled with grease. That works out to about 5 grams. I warmed up the headstock to expand the bearing journals. Well, let's go for it. Well, sure enough, slipped straight in. Oh, cool, spring's coming. First of the tulips are coming out. Well, at first glance, there's absolutely no run out. I was wondering how I was going to keep the second belt from touching the spindle when it's not being used. And I was thinking of using some sort of a masking tape or electrical tape, but of course the tapes always get really gunky over time. My mate Jörg came up with the idea of just put a magnet on it. That's going to work perfectly. It doesn't even touch the spindle now. Well, you know, I think I'm finished for another week here. Thanks a lot for watching.